So it means that each group is going to come to physics lab for only one day, right? And there you are going to be there for 4 hours with half an hour break for your break lunch. So in 4 hours, you have to perform the 4 experiments, right? And that's the reason why I thought I should be revising the experiments with you, so that when you come to the lab, you are quite confident of doing the experiments, because I may not be able to demonstrate all experiments. Happy Ganesh Chaturthi, Shivansh, to you too, to everyone. So, yeah. May you all be blessed with the wisdom that Lord Ganesha has, and the hard work, and of course, success. Yes, thank you. You are all, you know, you all have our best wishes always. All teachers, everyone's best wishes are always with you. So whether we say it or not, whether we scold you, whether we are angry with you, whether we are cross with you, but at the back of the mind, we are your well wishers. So whatever we do it for your good only. Right? So let us start. And I wanted to start with the meter bridge, because that was the very first experiment that we had done. Now, I want you to, all of you, to pay attention to the precautions that I am going to share again while we do the experiment. Or would anybody want to share the screen and show the experiment of meter bridge? I think that will be great using OLAPs. Any one of you can share screen and show us the working of the experiment. That will also tell me that you people have, you recall how to do the experiment. Anyone can do that? Hmm? None? None of you have none of you are able to share your screen?
Partly only.
Yes, Shivansh?
I remember it partly, not fully.
Okay. So what I'm going to do is I am going to share my screen, and you are going to help me do the experiment. Okay. So we will be using meter bridge experiment to find resistance of say more than one wire, and that is your experiment. So basically, let's take the aim first to find resistance of the given wire. And yes, specific resistance is not a part of the syllabus for this year. Only the resistance is what we have to find out. So what are the precautions that we need to follow in this experiment? What are the precautions that we have to follow? Anyone can answer, children. Whosoever remembers what precautions we follow, you can share with the class.
And the jockey should not be there along the wire, it should be just there, because
Right,
then the cross section area will be changed.
right. Jockey shouldn't be pressed or dragged, or moved along the wire. It should only be lightly touched over the wire to make a contact and just complete the circuit. Otherwise, the cross section changes. Okay. Next precaution that you can think of, that you can remember.
And the connections should be tight enough, and the insulation of the wire should be removed completely.
Right. Insulation of the wire should be removed, and the connection should be tight. And also ensure that the unknown resistance, the wire whose resistance you are finding out, we will connect it in the left gap. So when you are standing in front of the meter bridge, right? So why I'm telling you all this is, children, let's be very practical. In 4 hours, everyone has to do 4 experiments, right? So you have a group of say 12 students in the lab, and with social distancing, so you will have to, I'll have to ensure that you all get a chance to do all 4 experiments. So as I said, I may not be able to demonstrate all experiments, and also may not be able to come to each one of you when you are doing an individual practical. Right? I think I'm audible. Shivansh, you can join back. Right. So That's also one of the reasons that I'm taking this revision class of practicals before we start. Also, remember that when you are standing in front of the meter bridge, the gap which is just across your left hand is the left gap, and this is the right gap. So, left gap and right gap. Unknown resistance in the left gap, resistance box in the right gap. So, this is something that you have to remember. Okay. Once you do that, you are going to put up all the elements of the circuit on the table, arrange them. So you are going to put the unknown resistance in front of this gap, resistance box in front of this gap. You are going to place the eliminator and the key and the galvanometer. Galvanometer needs to be connected to this central gap here, right? This will go to the positive end and the negative end will be connected to the jockey for the galvanometer. Okay. After you do that, you are to note down the least count of all instruments that you are using. So here you are using a meter bridge, note down its least count. You are using a galvanometer, note down its least count. Okay. Have you people noted the observation in the files from OLabs? Have you noted the observations in the files from OLabs?
No.
Did
No.
anyone? No. Yeah, you are not to take the observations. You are to only make the observation table, keep it ready. Now when you come to school for doing the practical, you will be taking observation then and there itself in the lab while you do the experiment. Okay. So that's how we will complete your experiment. So now let's start joining this circuit, and we are going to consider only a single resistor, this resistance box. Now here I cannot connect it here because this is what the circuit is all about. So it is just little opposite to what I have told you. What else needs to be connected now?
Ma'am, battery.
Battery
Battery
eliminator.
eliminator.
Battery eliminator. So again, see here in this, what I was saying is that the your battery eliminator's positive should be connected to that end of the meter bridge where the unknown resistance is. So in actual practice, when we will do the experiment in the lab, right, we will connect the unknown resistance in the left gap. So positive of eliminator will be connected on the left hand side, and the resistance box will be on the right hand side. So the negative of eliminator will go to the right hand side of the meter bridge. So it is the same thing except for the fact that here the gaps are filled with the opposite resistances. Once you do that, anything else that we need to connect in the circuit? What else is missing? We have to start the experiment. Okay, let's select some resistance from the resistance box. How does one select? How does a resistance box offer resistance? To when you take out a resistance from the resistance box, or when you plug in a resistance in the resistance box?
Ma'am, take
I'm
out.
take out.
Acha, I am not able to take out any resistance from this resistance box. What is, how, why am I unable to take out any resistance?
You can click on the black part of the box.
Okay, so you are remembering. So I have taken out 2 ohm resistance, right? A small resistance, 2 ohms, and I have to insert the key. So key is closed. Now first, what is the first step that we do? What
Ma'am,
is
we
the first?
and jockey on the two screen to check that the current in and so the deflection we get in both the sides.
I am not getting any deflection. क्या करें अब?
Then we have to do remove key below that,
Hmm?
and there can and the where we have the option to remove the key. Below that there is jockey and jockey position from where you have to move it. Below that.
Ah, no, I have to insert the key, right? Okay, thank you. So we have to check for both side deflection. Here I'm getting 30, and on the other side also. Yeah, this will show us some trouble. Not, is anybody getting full scale deflection on the other side also?
No, no.
Nobody. So let us see if we can now get zero deflection. So we slide the jockey and look for a zero deflection on the meter bridge. So this was also giving trouble. Did anyone get zero deflection?
Coming at 33.3.
33.3. Acha, Shivansh, you can share the screen then.
Okay, ma'am.
Yeah, please do. Let us see. So now Shivansh is able to recall the experiment. Okay, Shivansh, share your screen.
Ma'am, I hope it is visible.
Yes, it is visible. Slide it on either side, beta. Okay. Hmm. Right. So you are going to find out the null deflection. So it comes at 33.3 centimeters. That is what Shivansh has got. So you are going to note this down as the balancing length, that is L. Acha, when you are taking the observation, now the precaution is you have got the null point, right? So you are to keep holding the jockey at that particular point on the wire, and with your right hand. With your left hand, you are to switch off the circuit, that is the eliminator, because you don't want extra or excess current to flow through the wire of the meter bridge, because that is going to heat it up, loosen it up, and it's going to, it's going to change the resistance. So you have to first thing switch off, and without moving your hand from where you got the null deflection. And then after switching off, you have to use a scale. Place it on the meter bridge. There is a scale on the meter bridge also, and read the reading on the scale of the meter bridge at what length you are getting the deflection, zero deflection. So this 33.3 you have to read from the scale on the meter bridge. So that's your balancing length. And of course the other length 100 minus L will be the other length. Now you have to repeat this process. Now Shivansh, can you take the observation for, let us say, 4 ohms, right? Yeah, you can fill up the table. Let's fill up the table also. Heading is not given. You have to write the heading. Generally, the heading is already given, isn't it?
Yes, ma'am. It's not even allowing me to write anything in the table.
Okay. Okay. So take the observation for 4 ohms now. You have to take your observation in steps. If you have started with 2 ohms, next observation will be 4 and the next will be 6. If you have started with 1, then you can do 1, 2, 3. Likewise. Okay? Yeah. Four ohms. Okay. Both side deflection. The other side deflection is not coming. Acha, remember one thing, Shivansh, just stop here, beta. If you are not getting both side deflection, it means that your bridge is not balanced. So, will this come if you lower the resistance or increase the resistance?
Ma'am, in OLAP, it is like this only. It won't come.
It won't come. You have checked with higher resistance, lower resistance.
Yes, ma'am. Low also, high also, and even the
Oh,
readings will be same.
okay. That is why OLAB will not be a very reliable source of observations, isn't it? Learning is not happening in this, more or less. Because, yes, Shivanshu, carry on. Mm, see,
Ma'am,
zero
it's not even
deflection.
good.
3.3 only.
33.3 only.
Yes, ma'am.
Okay. Move it slowly, Shivansh. No, it's not coming at 33.3.
Ma'am, because in my it was coming.
Actually, your apparatus, it was coming. Right. So now you understand what are the hiccups that you will have if you don't come and practice in the lab. isn't it? OLabs will give you an idea as to how to go about the experiment, but the actual practice will come only when you do the experiment in the lab. Okay. Any queries in this experiment? Shivansh, now you have recalled the experiment. Rubika, Aris, Prisha, Divyanshu, Sudeshna, is it fine with all of you? You will be able to join the circuit and do the experiment?
Yes, ma'am.
Because I am assuming the ones who did not join, they all know the experiment. They will be able to handle. So when they come to lab, I will not bother to think of helping them because they didn't come for the practice class also. So they know all experiments. Well and good, very good, great.
Ma'am,
So they
if in
will,
your lab both side diffraction won't come like here, so what to do?
yeah, good, good that you have asked. Now, what are the reasons for not getting both side deflections? In theory, we have studied, right? So,
Ma'am, either the wires are not connected
okay,
correctly.
okay. What else? Anyone else? Piyush has told us that wires are not connected correctly. Any other reason that both side deflection is not coming? Hmm? Okay. One reason is that connections are loose. Okay, means the connections that you have made are loose connections. There are, while you are tightening up the wires, there is insulation that has already gone into the connection. Second reason is that the positive terminals are not connected to one end of the meter bridge. All positives have to be connected to one end. So end on the left hand side of the meter bridge will be considered as positive. So where you are connecting the unknown resistance, that is positive, right is the negative. So which means eliminators positive must also be connected to that particular end. Third reason is that the bridge is not balanced. That means the resistance that you've taken out from the resistance box is not able to balance the bridge. So you need to look into the resistance that you have taken out from the resistance box. So that you will have to change. Okay. And fourth reason is at times what happens when you're doing the experiment in the lab, you can all see that there are these metallic strips at the end of the meter bridge. Can you see these metallic strips at these ends?
Yes, ma'am.
So these metallic strips sometimes, they also give us trouble. The contact is not perfect there. So what we generally do is then we remove these metallic strips and we just connect to a connecting wire between these two terminals, this one and this one. We connect terminal wire, we connect connecting wires. So we make the contacts secure. And then, of course, we do get both side deflection. One very far-fetched reason could be that the cross-section of the wire has changed because see over the years, though every year before the exams I do get the wire changed, but sometimes while children are practicing that they also damage the wire. Just as I said that you only said that you should not be pressing the wire hard on the jockey hard on the wire, or you should not be passing large current through the wire. I mean, you are not taking observation and you have kept the circuit on. So that also changes the resistance and the cross section of the wire. So that should also not be done. So these are few reasons, and one more reason could be the voltage that you have supplied from eliminator. Sometimes the 2 volt that you have supplied from eliminator doesn't give you both side deflection. Ideally 2 volt, but sometimes 2 volts doesn't give you the deflection. So you have to increase it to 4 volts. So at 4 volts it starts working. So these are the few things that you can try yourself before you call me that ma'am we are not getting both side deflections, right? So these are the steps that you can take yourself and check, right? Shivansh is still trying to get this null deflection. Yes, Shivansh, able to get the null deflection. Okay, Shivansh has stopped presenting. So now we move on to the next experiment, and that is potentiometer. Who would like to share screen and uh, show us the working of that experiment? Anyone?
Ma'am, just to inform you, ma'am, actually Ritika texted me about 10-15 minutes back that she was having some power cut issues, so she would be back in 5 minutes. I could
Okay,
not inform you.
no issues. So who is going to explain the E1 by E2 experiment? Piyush. Okay, great, lovely. Peter, this is sonometer.
and then with um,
Okay,
volt.
you want to demonstrate sonometer?
uh,
Okay.
because the second experiment is this only.
अच्छा ठीक है. Okay, fine.
Okay,
ठीक है.
ma'am.
Yeah. Acha, here I want to tell you one thing before you start, right? Don't just start connecting. So what you will have as a source is a step down transformer. Okay. You will have a step down transformer. Let me see if I can get an image of the step down transformer. I'll see if I can make videos of experiments in the lab, because again next week I'm going to school, so probably I will be able to do that. Let me see if I can show you an image of a step down transformer, the one that we have in the lab, you know, so that it is easy for you to uh, correlate as to what is it that we are using. Okay, no, these images are different. Right. Acha, once Piyush finishes sharing the screen, I will tell you. So step down transformers, you will have terminals. First terminal will be 0, then you'll have 2, 4, 6, 8, and 10. Your connection, you have to connect between the two ends of this wire, the sonometer wire, which is a brass wire, non-magnetic brass wire. You will connect it one end here, so 0 volts at one end, and you will be provided with a very long wire. You will connect it to 6 volts and then connect the other end of the wire to the other end of the wire on the sonometer, right? So 0 and 6 volts. So output is 6 volts, input is 220 volts, so that's as a step down transformer. You will put slotted weights here and you will start from the maximum. Right here to Piyush, what is the maximum that we can put in the hanger? Yeah, maximum is only zero point 0.5 kg. In the lab, you will be putting 1.525 kg as the maximum weight, the slotted weights. Okay. Okay, now function generator, frequency generator, just check type of AC supply.
Ma'am, there is main AC main.
We have to use AC mains, right?
Yes, ma'am.
Yeah. Copper wire, no, we are not using copper wire. Change the wire.
Ma'am, which are wires?
What is the drop down menu? Let me see. For the wire, is there no drop down menu? Yeah. It's not changing.
Ma'am, I am can't. Ma'am, can you see now?
Yes. No, we can't use steel. No, we can't use steel. Not even nichrome. Not even nichrome. Constantan, no.
Ma'am, there are only four options.
Okay, then we have to go with copper only. Yes, because copper is non-magnetic, right? Is copper magnetic? Is copper wire magnetic? Is copper magnetic? Para, dia, ferro, what is it? No answer. Piyush, what is happening?
Ferro. I
Copper is ferro.
not ferro. It's parodiet.
Copper is, I guess, diamagnetic, if I'm not wrong. Hmm?
Yes, ma'am.
Ma'am, because there are some alloys also.
So let's just try with copper and see what is happening. You can, frequency is 55 kg.
Ma'am, with AC main we can't change the frequency.
But then why it is 55 kg? 55 kg, I mean, unit is
Ma'am, you
incorrect.
should
Anyway,
take it as generator. Ma'am, the frequency generator and it changes to
no, no,
hertz.
it will not be frequency generator better. You are using an AC mains only. You are not using a generator, right? So let's start the experiment. Let's see what is the answer. What is it that you are getting? Okay.
Yes, ma'am.
No, keep the bridge position at A only. No, 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 no. A bridge is to remain at 0, right? Have you fixed B? B is at 100. Yeah. You got the first resonance. Rider has fallen off, right? So what is the length?
I'm 96.1 centimeter.
96.5. So remember one thing, that this is a little, its scales are opposite. So when we will be doing it in the lab, the wedge that we are keeping fixed, the wedge that we are keeping fixed is going to be at 0, right? Which is here also at 0. And the wedge that we are going to move is going to be at 90, I mean, at, which is the one which is going to be moved. To your first resonance position, now here again, it will be length increasing and length decreasing. Piyush, can you just reset it? Yeah. So what I mean by saying this is that your first observation should, when you want to start your experiment, Piyush, can you power on? Okay. Now, when you, after you have switched on the circuit, your bridge B should be somewhere at around, say, you have started with 1.25 kg, right? So the relation between resonating length and tension, what is the relation between resonating length and tension for a vibrating string for a particular frequency? What is the formula for frequency? Rubika? Yeah.
Anything.
Okay, Rubika, first let us,
Ma'am.
yeah, no issues, no issues. Yes, Rubika. Formula for frequency, can you tell us? For a vibrating string. Okay, Aris, can you tell us? It's okay, bacha. Aris, what is the formula, beta?
Uh, Ma'am, 2 pi f equals to uh,
Beta, formula for vibrating string. A string that is vibrating between two fixed edges. We did it in class 11th also.
ma'am, I don't remember, ma'am.
Don't remember. Okay, honest answer. Sudeshna, would you be able to tell us?
Ma'am, I don't remember.
Okay. Shivansh,
Ma'am, I would go with Sudeshna.
how nice is that? I will go with Sudeshna.
Ma'am, 1 upon time period. Ma'am.
Of course, one upon time period, but then it is for a string that is vibrating between two fixed edges, between two fixed ends. Piyush will go with Aris. Yes, Piyush? Piyush, your audio is a lot of disturbance. Why don't you just go to theory in OLabs? From simulator, go to theory in OLabs. Right, and scroll down. Move down, move down. Here. What is the formula for frequency? Nu is equal to, yes. or the first formula. Nu is equal to 1 by 2L under root T by M. T is the tension, M is mass per unit length of the wire. So how is length related to tension? Aris, can you tell me now that you have the formula?
Yes, ma'am.
Waiting.
Ma'am, 1 upon 12 root T by M.
So how is resonating length dependent on the tension? How is this resonating length dependent on the tension? The slotted weights that you have put. How does it depend on the tension? Resonating length is L in that equation.
Ma'am, directly proportional to the root of T.
Absolutely correct. Resonating length is directly proportional to the square root of the tension. So, which means larger the value of the tension, more will be the resonating length. And smaller the tension, less will be the resonating length. Because frequency is something that is constant, 50 hertz, alternating current. And M is mass per unit length of the wire on the sonometer. So that I will tell you what is the mass per unit length, which is 0.0017 kg per meter, because we are having the same wire. So, Piyush, can we go back to the simulator? Yes. So what you will do is, say you have put in, say 1.5, 1.25 kg weight in the slotted plates. So you have to put your the bridge or the wedge B, which can be moved out. You have to put it at say 50. You have to start from 50. And then once you start the experiment, you will have to slide it outwards. One is fixed at 0. The other one you are going to slide outwards. So you have to increase the length. You have to increase the length, the gap between the two wedges. And then where the rider falls off, that gives you the first resonance position for length increasing. This is what we call length increasing, right? So Piyush, can we see the experiment again? Hanger weight needs to be chosen, beta. Power is on. Yeah, okay. Choose some weight of the hanger. Make it 0.5 kg only.
Mine is point 0.7.
Okay. So you can now slide the jockey. See here what you are doing, here you are decreasing the gap, but in actual practice you will have to start from a smaller gap and then increase it. .1 I think was the, yeah, you can now increase. Well, good. So now this is how you are increasing the gap, and we will wait where the rider falls off. Okay.
I mean, it wasn't falling from me at all.
Is it?
Yes, ma'am. I had to change the magnetic position. I don't know. I changed it, and then it fell.
Magnet.
Yes, ma'am. The point where the magnet, this radar is placed, and the magnet.
Acha. Did it fall after that?
Yes, ma'am. I had to again adjust the bridges, and then it fell. Otherwise, it was not falling at any point.
Okay. Here also it is not falling. Earlier it was falling at 96.1, right? So let us change what Shivansh is telling you. Change the position, Piyush, of the rider.
And from magnetic position bar.
Bas, that's it. Let it be. Now decrease first. Start from a smaller value of bridge B. In the lab, when you will do this experiment, there will be no, you will not come across this issue. Yes. So now you are getting the first resonance length at 52.8, right? The rider has fallen off. So this will be considered as length increasing position, 52.8, because here the weight is only 0.5. So smaller the slotted weight value, lesser is the length. Okay. Then you have to take the second resonance position, which is from 52 only. For this particular tension, you have to again decrease it. You will get two positions. I don't know whether we can see it here. Can we check this here for second resonance, Piyush? Decrease the length. I don't know where it is coming. OLAB is not giving us the second resonance. Does it give us? Check. This is the first only, na? What about the second resonance?
Ma'am, it is not giving.
I think you will have to against the race of the rider.
So he can place the rider again, but you have to change the position of the rider, I guess.
Yes, ma'am, I
Ah.
understand.
But in actual practice, in the lab, you don't have to do that. You don't have to do that. You will get your second resonance position. Okay, increase it. This one I have to demonstrate. You are again getting the first resonance. Okay. Second resonance is not coming. No. Piyush, okay, observe what happens. See, whether you are changing the magnet position or not, for this particular slotted weight, your resonance length comes at the same point, isn't it? 52.8. So it's always the first resonance position. You are not getting the second resonance position. So that is what we will have to do in the lab. You have to take two resonance positions. Okay. And then take the mean of that. Can you scroll down to the observation table? Switch the power off, Piyush. Switch the power off. And go to the observation table. Oh, no observation table here. I guess in theory or procedure should be. Okay, let's check. Yeah, here. Observation table. Uh, Now this observation table we are not using. Is there any other observation table? There will be one more, I guess. Yeah, this one. No, this is also not, we are not using this one. Okay, there is no other observation table. Is there any other observation table for this experiment? In theory, you can check. Any other observation table that is given? Yes, Piyush?
No, ma'am, it is not.
No. Okay. So you have to follow the observation table that I have shared with you. Right? I have shared an observation table with you. We will follow that observation table and accordingly we will write down the answers. First observation, you note down what is the tension, what is the mass, what is the tension, then first resonance, second resonance, mean, and then formula. 1 by 2L under root T by N. This one I will have to now demonstrate in school because this is not showing. Yes. Now who's going to demonstrate using OLAPs E1 by E2 potentiometer? Usually comparison of EMS. Piyush, you want to demonstrate this experiment? Acha, what are the precautions that you are going to follow for sonometer experiment? What precautions? What is the most common precaution that we follow for all experiments? That we are not to
Ma'am, the
pass.
large current should not be passed.
Yes. Unnecessary current should not be passed through the apparatus because this wire will also get heated up and change the dimensions of the wire, right? So that you should not be attempting at any point of time. Now for E1 by E2, let me share the screen.
And the
So
practicals in the school we will be doing in pairs, like you told
no,
back then.
no, we'll be doing individually,
Okay, ma'am.
not in pairs. Otherwise, how am I going to ensure social distancing? Yes, Shivansh,
Yes, ma'am.
right? If we're doing it in pairs, then we should be over with 2 days, isn't it? I should be over with experiment in 2 days. Now, yeah, approximately 2 days I should be over with it. So now we are calling you for 4 days, 5 days, starting from 20th of September. So that's how it is. Okay, so
Okay, ma'am.
here again, yeah, here again, what do you think will be the precautions that you will take? Same as meter bridge, some of the precautions are same as meter bridge.
The
That
positive
you,
terminal.
yeah. All positives are to be connected at one end. Jockey should not be pressed on the wire. Large current should not be passed through the circuit unnecessary. And these are the main precautions. The other precaution that is to be followed, because you are using primary cells, one Leclanche and one Daniel cell. So you will be only see the both the cells. Let me just choose the other cell. Secondary cell will be your Daniel cell. Okay. So one cell is the Leclanche, the other one is the Daniel. So this copper vessel is Daniel and the plastic vessel is Leclanche. Both these cells have zinc rod as their negative electrodes. So the negative electrodes are to be put into the electrolyte only when you are taking the observation. Otherwise, it gets consumed. So you have to ensure that you are not consuming the zinc rods completely before your exams. Okay. So we will start joining the circuit and we have chosen the cell. We will first cell. So how are we going to connect all positive terminals? Oh, well, how do I start the circuit? Yes, class? It's a Daniel cell, 1.08 volts. Can I select these voltages? No. Then how do we connect the circuits?
Connect the circuit first.
Hmm?
By clicking on the red dot on the battery eliminator,
Okay.
and then you can drag the wire to the
But
positive
I can't see the wires. It's not working for me.
Ma'am, you have to click on the blue and the red.
No wire is coming. See? Nothing is coming. So what do we do? Let's refresh and see what's happening. Okay. 1.08. It's not letting to choose also. Earlier when I have demonstrated then this experiment while in the class while I was discussing the comparison, I have done this experiment, isn't it? Okay, who is going to share the screen for whom it is working? Let me check why it is not working. Meanwhile, who will share the screen? Shivansh, why don't you share the screen now?
ma'am. I'm not
You
very
can't?
clear with the connections, ma'am.
Huh?
Ma'am, I can try, but I'm not very sure about the connections.
Okay, try. It's okay. I'm going to help you. अच्छा, Piyush is presenting. चलो.
So then must
Yeah.
I make start making the connection?
You can start. Choose the second cell as Daniel cell. Okay. Yeah, I'm not getting these wires. How funny. Okay. Positives. Piyush, first connect all positives. So Daniel cell copper vessel is the positive, right? Leclanche cell carbon rod is the positive. No, this is not carbon rod. First you connect all positive. Daniel Leclanche cell carbon rod, yes. All positives will be connected to one end. Okay, now negatives. Zinc rods two. Yes, this is a two-way key. Okay. Then this will go to galvanometer resistance. Okay. Now remember, just stop Piyush here. But when we are doing this experiment in the lab, this high resistance we are not using in the circuit. The high resistance that we have here, HR 2 kilo ohms, we are not using this in the circuit. But otherwise, what is the role of this high resistance in the circuit? Why are we
And to
using this?
prevent passing of huge current from through the circuit.
To prevent large current to pass through the galvanometer. So it will protect the galvanometer from getting damaged. Okay, correct. But otherwise, we are not using it because we are not passing large current through the circuit. Assuming that you are not passing large current. Right, now complete the circuit, Piyush. Okay, perfect. To the jockey. Okay, right. Okay, now stop here. I want to ask you, this is a rheostat, right? So why did we not use the lower terminals, both the lower terminals to make the connections?
And then we can't change the range and it will be constant.
Then we can't?
And even if we slide the bar, if, then also the resistance will be constant.
Yes, because once you connect the terminals, lower terminals, you are actually using a complete resistance. And this rheostat has a reading on it that the rheostat resistance is 1 ohms. So when you connect the lower terminals, you are not able to vary the resistance. So you will keep a constant resistance of 1 ohms. But if you use one lower terminal or the sliding terminal and diametrically opposite lower terminal, then between this sliding contact and this lower contact, the resistance is 1 ohm. So you can slide the jockey, not the jockey, but the slider, and you can change the resistance that you are putting in the circuit. Okay? Okay, Piyush, go ahead, beta. Good. Right. Now we are using one of the cells, right? Okay.
Ma'am, R should be 1 ohm or I.
Uh, Let it be 1 ohm. Let's see what is your observation. Make it 1.5. Okay, 2 ohms. Fine. Perfect. Now the first step. Beta, first check both side deflections. Yeah, touch at this end. Shouldn't be zero. It should give you some deflection.
Ma'am, you will need to take it somewhere below because at the top it's not giving
Yes.
-30.
Piyush, you will. This is not touching the wire. The jockey is not touching the wire. Right? Go down. Yeah. Once when the wire is being touched by the jockey, you can see the. No, you slide it along the wire. Okay, you try yourself. Let me see what you do. Yes, you will see the blue line, right? So here you are getting 30. Go up to the last wire. Yes, again minus 30. So it gives us both side deflection. So this is the first thing. But in actual practice, You will check for both side deflections by touching the jockey at the two terminals, right? Upper terminal and lower terminal. Okay. Now you can take the observation. You have to get null deflection. Will be lower than this, na beta?
It should be around 770.5.
माइनस बेटा -30 एंड +30 के बीच में आएगा ना. इट विल बी समवेयर बिटवीन -30 एंड +30. Yeah, this is -30, so you have to, yeah. Mm-hmm. Right. So it's coming here at 790. Remember, in the lab, you do not have a 10-wire potentiometer. You have a 4-wire potentiometer. The potentiometer has only 4 wires. So it's a length of 400 meters. Sorry, 400 centimeters. My bad. 4 meter or 400 centimeters. So your readings will be different than this, but it should give you the idea. The first is to check for both side deflections. We should get 30-30 on both sides. Then we slide it, or then we take it over the wire and note down the observation. So, can you, Piyush, come to the first wire? Any observation on the first wire? Any reading? Yes. Just put it on the first wire. So, first wire it is 5.9. Second wire? So, length of first wire is 100 centimeters. Okay. So any reading that you get on first wire should be between 0 to 100. Second wire is 100 to 200. So any reading that you get should be read as 100 plus whatever is the value. So this 193 is 100 plus 93.2 on the second wire, and 100 is from the first wire. Okay. Now we come to the third wire. Okay, so third wire starts from 200 to 300. So your reading on third wire should be 200 plus whatever is on the wire. Next, fourth wire. Yes, fourth wire is 300 to 400. So likewise, you keep on adding 100 as you move ahead into the wires. Okay, so that's it. I think we will discuss up till the fourth wire because we have 4 wires in the lab. The potentiometer has 4 wires. Okay, so what will be the next step now after you have done this experiment for one cell? What about the next step? What are we to do? We are going to, okay, connect the next cell. Plus 30. Check for minus 30. Okay, 0 we have already got. So tell me now, this is 789.5 and earlier one was? What was the earlier value for the other cell? Did anyone note? Did anyone note?
790 something.
790. Okay, let's see, it was 790. So then this is the same cell, isn't it? 790 and 789.5 is the same cell. Did we change the cell, beta? I think we are on the same cell. Move back, move back. Lift it up, take it back, and then no, it's OLabs will give us this trouble. Yeah, I think now. No, it is again the same cell. No, it is the same cell, Piyush.
Ma'am, for me, one value is coming out to be 789.5 and one is to be 770.
For the other cell.
Yes, ma'am. I got two values.
Can you share your screen?
Yes, ma'am.
Okay, Piyush. Thank you, Bata. Let Shivan share his screen and show us the second observation. Okay, this is the second cell, 789.5, right? Hmm. Yeah, it's correct. You have connected to the second cell. 7, 6. And then, nahi, Piyush. Shivansh, it is the same cell, na? It is the same cell. No, no, it is the same cell. It has not. Acha, you have connected both as Leclanche cell, Shivansh. Have you checked? Both the cells are Leclanche.
I mean, comparison of EMF, I'm getting these two cells only.
No, you have to choose the second cell.
Oh, okay, ma'am. I
Second
got it.
primary cell, you have to choose from the drop down menu. You have to choose a Leclanche, not this one, second one. Yes. Change it to a No, you change the first cell, beta. You change the first cell. First cell will always be Leclanche. Second one will be Daniel. Right. Now you try for the second cell, the Daniel cell. Okay, yes. Check for both side deflections. Minus 30, plus 30. Okay, find 0. Okay, 0. Null deflection. Right. 568.5, right? So, what conclusion you can draw between the EMF of the cell and the balancing length or the null deflection length that you are getting in the experiment? That more the EMF, more is the balancing length, which is the principle of the potentiometer. Leclanche's has a greater EMF, whereas Daniel cell has a lower EMF. So in this way, you will have to take three set of observations. So Leclanche, Daniel, Leclanche, Daniel, Leclanche, Daniel. Three set of observations. And how you will take the observation is you will just first set done, you will just slightly change the position of the jockey and repeat the experiment. Then again, when second set is done, slightly change the position of the jockey and then take the observation. So that's how you will take three observations. Yes, Piyush. Yes, Piyush.
Ma'am, we will change the value of the ma'am, we will change the value of the jockey or the rheostat.
But a jockey, how can you change? Jockey's
I
position will dip. Yeah,
ma'am, you were saying jockey, we will change the jockey.
did I?
Yes, ma'am.
I said to change the position of the rheostat.
Ma'am, for
Slightly change the position of the rheostat. Okay, if I said jockey, then that's not how it should be done, right? You have to change the position of the rheostat. By jockey, what I meant was the sliding contact of the rheostat. So you'll slightly change the position of the rheostat, the sliding contact of the rheostat for every set of observation, and then take your observation for each set. Okay, three set of observation is to be taken for this experiment. Okay, so except for the position of the rheostat, nothing else is to be changed while you perform the experiment. Okay, any queries, children? We are already into time. So I'll be taking up the last experiment, which is half deflection. I'm going to share the video of half deflection that I have from the lab for all of you to go through, because that is exactly the way you will do the experiment in the lab. Okay, that I'm going to share. Meter bridge also I will be sharing, but not this week. I will share it next week so that it is fresh in your mind and you are able to do the experiments properly. Any queries, children, that you have up till these three experiments that we have revised?
No, ma'am, all
Aris,
clear.
No,
yes,
ma'am. Yes.
Shivan,
I'm
it
all
is clear.
clear.
So you need to perform the experiment without my help, right? When you come to the lab.
Yes, ma'am. I just wanted to ask about that because I have checked the no option. So will I also come or we cannot come?
You can change, I guess.
Uh, I've already
Let
submitted.
Acha. Okay, fine. Let me. Actually, there are many children, and every day the numbers are changing. So what I'm going to do is I will wait till today, and then I'm going to ask Devjani ma'am, and she can ask ma'am, and I'll get back to you. See,
Because I only want to attend the practicals, the days of the practical.
I guess you only have practicals.
So there are no revision classes.
How can there be, children? We are calling you only for from 20th, 21st, 22nd, 20, 21st, 22nd, 23rd, 24th. 5 days we are calling you. Yes, Piyush. Piyush is having a very bad audio connection today. Can't hear you. Piyush, type in the chat box, beta. Yeah. We are coming, you are coming to school from 20th to 24th for the practical. And then your practical exams are going to be conducted from 27th to 1st October. That is when you have to come to school, isn't it? Aris,
Okay, ma'am.
you can't
Because
write the, yeah. Your board practicals are going to be conducted 9, yes. Yes, Piyush, it will be from 9 o'clock to 1:30. Okay, 9 to 1:30 will be your timing. Half an hour break you will have, and rest of the 4 hours you will be in the lab doing the experiments.
okay, ma'am. Then
Yes, Piyush. So that is how it is. And when you have the exam, you have to come. Na? They can't. They're not online. They're offline. Practicals is offline only.
so, ma'am, we
So
will be called only for the practicals the whole day.
you have 5 days, right? Aris, you have bio.
Yes, ma'am.
So you have a 1 day for bio also.
Yes.
1 day practical is for bio. 1 day is for physics. 1 day is for chemistry. So between these 5 days, you have to be in school for 3 days positively,
Yes, ma'am.
right? And then of course when it is time for your practical exam, that day also you have to come for your physics, chemistry, bio. 3 more days there,
Okay, ma'am.
right? So that I am going to find out from Devjani ma'am, that all those who have given a no, how it can be rectified, because without a consent I don't think, and a written undertaking, we will not let any student come to school,
Yes.
isn't it?
Ma'am, I
Yeah.
was asking because I think that Dimple ma'am said that we will be doing questions and all that also. So that's why I thought that we will come for revision classes. That's why.
Okay. What I think is, yeah, you may be right, because timetable I haven't received. So it will be positively, it will be like that. See, for 3 days you are coming for practicals, isn't it? And the rest of the 2 days, what will you have?
Hmm.
Rest of the 2 days, like when, uh, for me, I'll be busy for all 5 days. Okay. So there will be no physics theory class around that time. So are over with the first term syllabus. I think I'll just take one more class where I have to discuss LC oscillations, and then do some questions. That will be the end of term one syllabus. So the theory part is over, and I'm sure for all the teachers it is over. So when you are in school, that I am busy for all days. Chemistry ma'am is also busy for all days. But for bio, it is only 2 days. So rest of the 3 days, there are batches which are not doing any practical. Then and they will have some theory class like question answers. I think so. I'm not sure, Aris. I will be able to confirm all these to you once. You are superhuman, right? So, Aris, I will be able to confirm once I get the timetable, right?
So, ma'am, at that time, will I be able to change from no to a yes?
I'll tell you one thing.
Ma'am, the responses are
This is
still
between you
allowed.
and me, and all rest of you. You can close your ears. Okay, you are not listening. Aris, this is just between you and
Yes,
me.
ma'am.
You can put a yes, right? And you come only for the practicals.
Yes, ma'am. That's what. Uh,
So that's it. The days you don't have practical, you don't come. Simple.
yes, ma'am. Okay, ma'am.
Yeah. So
Yes, ma'am.
others have not heard about it, right? Shivansh, Piyush, Sudeshna,
No,
Rubika, you
ma'am, we
didn't
did
hear
not hear
it, right?
anything. We did not hear that you suggested to come only for practicals.
Ma'am, I
That's bad, Shivansh. Yes. Okay, now Shivansh was saying something. 17 practicals. No, I don't think you will do 17 practicals. You will be doing, I think, one volumetric and chromatography, and I think three salts. That's it, I guess. Not more than that. Why do you need to do?
Yes, that the term one and term two combined, all the 17, I think. So we will do only term one.
Has man combined everything?
Ma'am, I'm not sure. I think
What are
We have
you?
written 17 practicals till now in our files, that's why I was saying.
But those 17 practicals are for term one only.
Ma'am, that we don't know.
ma'am,
It
Beta,
is, I
ma'am
don't,
ने share. Shivansh, ma'am has shared the
I
syllabus
haven't
in
looked up.
the classroom, isn't
Ma'am,
it,
I
for
didn't
term
look up
one?
for the practicals till now.
Huh?
I
What?
didn't look up for the practical syllabus till now for term 1.
That's bad. That's bad. See, even for physics, I'm going to make you write three activities. Okay. Because there are three activities that you have to write, which is not to be performed, but you have to write. And how much is that, Piyush?
ma'am, almost more than 12 experiment is there.
For chemistry.
Yes, ma'am. It's
Actually, you see, in
almost
chemistry, you have the salt analysis, isn't it? So,
yes,
anion, cations, and so you can, like, if I want, as a chemistry teacher, I can make you do 20 salts, but if I want, I can make you do 5 salts also. So, it depends. But not 17. I am sure that ma'am will not make you do 17 experiments. Not possible. In 4 hours, how can you do 17? You will be doing a volumetric, definitely. You will be doing the chromatography that I know Pooja ma'am has shared. And you will be doing some salt analysis. How many that I don't know. Maybe four, maybe three. I don't know. Okay. So that's it.
Thank you, ma'am.
That yes, thank you so much, class. Thank you. And please do revise as and when you get time. It's just a way of unwinding yourself. You can open O labs and do practicals. Okay? Chalo. Okay, take care, children. Bye.
Thank you,
thank you,
ma'am.
ma'am.
Thank you.